Exception handling is in every programming language. And if you handle exceptions or errors properly, your program can actually continue running. You display a little message to the user so they know there was a problem, but the program does not stop. And so anything that you think could cause an error needs to go into something called a try block. And in Python, it's try with a colon, and then the code that could potentially cause an error is indented below try. Directly below try, you need an except block. Now, most languages call it a catch block. However, Python calls it except, probably because you're handling an exception that is thrown. So you need at least one of these. It has to be directly below try. Can you customize the except blocks? Yes. If you can think of a particular exception that might occur, you can actually say except space and then the type of exception. And if that does occur, you can handle that individually. So you can have multiple except blocks. You need to have at least one, and it needs to go below try. And typically in the except block, you will display some type of error message. Then the other two blocks are optional. However, I do think using the else block, coding that is pretty important, because if your code has an error, you probably aren't going to want to process the data, right? If the data threw an error, you wouldn't want to do the processing on them. You'd want to get different data. So the else block includes the code that you want to process when everything is okay. So when there is no problem. So you've got the code in your try block that could cause a problem. If there's no problem, it goes down to the except block and it runs that code. If there is a problem, it goes into the except block and it displays a message. So where does the finally block come in? Anything that you put in the finally block is going to run whether there is an exception or not. So in your try block, if you open a file using open, not with open, just open, then in the finally block, you actually want to close the file. If you want to print a parting message to the user, you can also do that in the finally block, but the finally block is optional. I mean, if you're not doing any kind of file processing, or if you're using with open, you don't really need it. So here is the syntax for a try block. And so here I've got two different numbers, and so I'm going to calculate a result, and I actually should have n1 divided by n2 there. Hold on a sec. Oh, that's so much better. So now I've got n1 divided by n2, which basically I'm trying to divide 1 by 0. That will definitely throw an exception. So anytime you're doing division, and there is a chance that the number you are using as a divisor is going to be a 0, you should put it in a try block. Below the try block is at least one except block. And if you want the default, it's just except, and then the statements that are going to process the exception. Now, in this case, what I'm looking for in particular is division by 0. And since I know that, I can say except 0 division error. Python has a whole list of built-in exceptions, and 0 division error is one of them. So if you want to see what the other ones are, I did include a link to the Python site, and it's going to take you directly to the different types of exceptions. Because if you know what Python calls the exception, you can actually put in a special case for that. And so here in my try block, I've actually created a division function, and I'm sending a numerator and a denominator to the division function. If the denominator is a 0, then I'm printing out a user-friendly message, and I'm getting a new one using the random number function, and I'm making sure that it's not going to be a 0. And then I try calling division again. If there is a different problem, okay, so if it's not a 0 division error, then it's going to go into this default exception block, just indicating that there's an error, they should try running it again. If you don't want Python to display an error message for an exception, but you want the exception handled so the program can continue running, you can use the keyword pass. And so here is an exception block, a default with the keyword pass. And that's all you have to do in order for the program to continue running. So here's a little file handling example. We are letting the user enter the file name, which can be dangerous. And as long as they don't enter a queue, we're going to keep processing. So here we are trying to open that file and we're trying to read it. And so this can definitely throw an exception. So it could be an end of file error, probably unlikely, which is why I've got just pass here. More likely is it's a file not found error. And so for that exception, we're basically telling them, hey, the file you're looking for, we're displaying the name, cannot be found. If it's a regular exception, we're doing a pass. Otherwise, if there is no exception, we're going to print the contents that we read in. And then we get to the bottom of our loop and we're asking them to enter the name of the file they want to read. Okay, so that's an example of where the exception handling will allow you to continue processing. And you can see we have the else block, which to me is actually a critical block because most of the time if I'm doing exception handling, I only want to execute code if there aren't any errors. So in my try block, if there is an error, I probably don't want to continue and execute the code. So the code that's in your else block is the code that you want to execute when there is no error. Okay, and so here is that same example. Obviously, if there's an error and they can't open the file or they can't read in the contents, then obviously I don't want to print the contents because they're not there. So that's an example of when you would use else. Okay, so here is the sample output where it's trying to open the character file, enter the name of the file. I first entered characters. I didn't put the txt at the end, and it's saying that it can't find it. So because I'm handling the exception, it comes back and it asks me to enter the name of the file again. And so now I did enter the correct name, okay, and it's displaying the contents. And just for fun, I did another one. Now, would this work if I wasn't in the chapter 10 directory? So when I'm running this, I'm actually in VS Code. I am in the chapter 10 directory. Would this work if I was up in the CIT 228 directory? No, I would have to put chapter 10 / characters.txt. Okay, so just keep that in mind when you're running code like that. Because we have the file handling though, if I did need to put chapter 10 in front, it would just give me a message like this, that it couldn't find it. The finally block is optional because it's always going to run. So even if there's no exception, that block is going to run. If you open files using with open, you don't need to close them in the finally block because they're automatically going to be closed. So the only time you have to actually worry about file handling is if you use open in try, not with open, just open. Then you need to close them in the finally block. So I did do an example showing you how that would work. And I've got basically a variable called file opened, which I set to false. And then enter the name of the file you want to read. And as long as they don't do Q, I'm going to stay in this lovely little loop. And this time I am just using open, not with open, and I'm trying to read. And so then I've got the various exceptions for if that file could not open or could not be read. And as long as they could open and read, I'm printing the contents and I'm indicating that the file was opened. So in the finally block, it's checking to see if the file was opened, and if it was, it closes it. And the reason I created that little file opened, I call it a flag, is because it could be the problem was opening the file, not reading from it. So if the file was never opened, there is no point in closing it. So that's why we've got that little flag. Here's another example. This is the division program that we were looking at earlier, but this is the full program. And you'll notice that I have a variable called quit. It's the sentinel. And I am going to stay in this loop as long as they don't type a Q. I'm getting random numbers. And the way this is set up is I very well could end up with division by 0. And so here I am calling division. I'm sending it the numerator and denominator. And so that could throw an exception. And here I'm handling those exceptions. And you've seen this code before. If it's 0 division error, I'm actually getting a different denominator and making sure it's not a 0. And because I'm handling this here, I don't really need an else. Okay, because if it is a 0 division error, the problem is the denominator. I'm getting a new one. If it's a different problem, I'm just printing out that they have an error, and then they have the option of continuing or quitting. So it'll just grab a different set of numbers. But regardless, after each run, it is going to print "Thanks for playing," just to kind of illustrate how finally works. So here's the first run. Would you like to continue? Cue to quit. So I just pressed enter. These are the two random numbers. Thanks for playing. Would you like to continue or quit? So by chance, I happened to get a 0 divide by 0 error, and I got a new denominator. These are the two numbers, and thanks for playing. Here I press enter. You can see it's got the two numbers. Thanks for playing. So, regardless of what happens, whether there's an exception or not, finally runs. So at this point, you've seen how to add exception handling to a program that's processing files. And you've also seen how to add exception handling to a program that has processing that could throw an exception, like our division program.